Hey guys, let's take a look at one of the product rule problems from your homework. This is number 28 from section 3.2. And what we need to do is we need to go ahead and rewrite this function so that we don't have that fraction. I can do that because it's just an x in the denominator, and all I have to do is make that x to the negative 1. So we can get away with it there and not have to use the quotient rule. All right, and then we use the first times derivative of the second plus second times derivative of the first formula for the product rule. So f prime of x is equal to the first times the derivative of the second. Okay, so our derivative of the second, we get a 2x from this, and then from here, you take the negative 1 down in front. There's already a negative there, so that's going to give you a positive 1, and then you subtract 1 from the negative 1, which gives you the negative 2. Then our second part is the second times the derivative of the first, and that gives you your, oh shoot, sorry, I just wrote the first down just like it was. The derivative of the first, which would be 6x. Okay, now, this gives us our derivative, so if you want to take it further than that, WebAssign should take this just as is, but I'm going to go ahead and take it where you can see, where we multiply this out, see if there's any common factors and combine those, okay? So let's use FOIL on the first thing. That's going to give me 3x squared times 2x, and then 3x squared times the negative 2, times the x to the negative 2, forgive me. The 2 and the negative 2 add out to 0, and that leaves me with just the 3. And then we've got negative 1 times 2x in the middle, negative 1 times x to the negative 2. All right, and then on the second part, we just distribute that 6x. So that's going to give you 6x cubed. And then 6x times negative x to the negative 1 is negative 6. Here again, we're multiplying the two bases together, so we add their exponents. If you add negative 1 to 1, you get 0. So we lose our x. All right, let's clean that up a bit. I do have some like terms. I have two constant terms, and I have two x cubed terms. So if we put those two x cubed terms together, we get 12x cubed. And then I would have a negative 2x. Then I would have the constants 3 minus 6, which is negative 3. And then I have the negative x to the negative 2 term there on the end. Now, you've got some options here. As far as I'm concerned for the test, this form's fine. So I want you to do a little bit more simplifying than just writing the derivative like it is here, but you don't have to go as far as you might need to if you were going to do something with this. Now, if we do need to set it equal to 0 to find a horizontal tangent, or if we need to do something else with derivative, then what we can do is factor out an x to the negative 2 and then pull it to the bottom. You can also do this as, if you want to, as writing this as 1 over x to the second power, and then getting a common denominator and working that for the whole thing. So a couple of different options there, just depending on how you want to do it. When you factor out a variable that's got a negative exponent, you have to keep in mind exactly what it is you're doing when you factor. When you factor something out, it's the same thing as dividing. So if I want to factor out that x to the negative 2, what I have to do is divide each term by x to the negative 2. When you divide like bases, you subtract the exponents. So your first term would be 12 times x to the negative 3 minus negative 2. Okay? And that winds up giving you x to the 5th, because you're subtracting a negative, which changes it into a plus, okay? Into addition. On our second one, we are dividing negative 2x by x to the negative 2. So that's going to be 1 minus a negative 2, which is going to give us 3. Then we've got, same thing here. So this is going to give us x squared. And then the last one is just going to give us 1 when we take it out of that last one. You factor something out of itself, it gives you a 1. Okay? All right, now what we can do is pull that x to the bottom, since it's got a negative exponent. And we have something that looks a little bit more realistic. We got a polynomial on top, a polynomial on the bottom, and we could do a little bit more with this than we could when we still had the negative exponent in there, okay? So this would be final form if you were trying to do something else with the derivative, like set it equal to 0 and solve for x, okay? But again, I'm fine here if you want to leave it before you factor that x to the negative 2 out, unless you are trying to set it equal to 0 to get the horizontal tangent and that kind of thing, in which case you will need to move it.